Welcome, geometry, to week number 20. So here we go. Side splitter theorem. What am I actually saying there? Well, we're going to be looking at triangles, which have a line cut in the middle of them. And so to put it in some more academic words, solving proportions with a side splitter theorem means we're looking at a triangle with a line that is parallel to one of the sides of the triangle and intersects the other two sides. So it just comes across and intersects the other two and divides those two sides proportionally. Which means when you have yourself your triangle, I'll just draw my favorite triangle here. We pick one of these three sides. I'll pick the bottom side. And we're going to draw a line in the middle so that it's parallel to it. Here, the sides that are intersected actually are cut proportionally to each other. And so, essentially, just like we've talked about with scale factor here, we have this smaller triangle up here. We have the larger triangle, which is the whole thing. And usually that's how we tackle these kinds of problems, right? We solve it based off of the big triangle and the little triangle. But, ladies and gentlemen, what I'm giving to you here is saying that rather than focusing on the whole triangle with the image over the pre-image and focusing on scale factor, we could just focus on these sides in purple. So rather than focusing on the whole side with the whole triangle, if it is this specific case with the side splitter theorem, then we only need to worry about using the chunks highlighted in purple. So let me go ahead and give you an example with numbers here. So let's say we have a triangle like we do up above. With our parallel line, and we're given the following information. Let's say that this is 2, 4, x, and 7. Ladies and gentlemen, as you can tell, the diagrams are not drawn to scale. But because of the fact we have the side splitter theorem, we know that x and 2 correspond, they match. We know that the 4 and the 7 correspond, they match. And so we can write our proportion without worrying about the whole triangle and instead just worrying about this part of the triangle. And so we can match it up and say that x over 2 is equal to the 7 over the 4. So notice what I did there? Both the 7 and the x are on top because they're on the same side. And so x over 2 and 7 over 4. And this will work to solve for x. Ladies and gentlemen, here's where sometimes it gets a little fun for some people. Because of the fact we're not worrying about scale factor, and we're just focused on the proportion, which is a fraction, which is a ratio part of our understanding, we don't have to match it up this way. We could also match it up with the x over 7 equal to the 2 over 4. So what did I do there? Well, rather than putting the x and the 2 in one fraction, how does the x match? With the 7 as well, because they're on the same side. And that matching, that correspondence is how you write your fraction. X over 7, and then the x and 2 are part of the same chunk in the triangle. So 7 and 4 are part of the same chunk in the triangle. The 2 and the 4 are on bottom, since they're on that side, and the 7 and x are on the top, since they're both on the same side on the other side. So whether you set it up like this because this is more intuitively understanding, or you set it up like this because this is more intuitively understanding, either way is going to work. Either way is going to solve. Ladies and gentlemen, you just have to double check your fractions to make sure that it matches the top of the fraction and within the same fraction. X and 7 are on the same side, they're both on top. X and 2 are both on the top part of the triangle, so they go within the same fraction. Here, X and 7 are part of the same side, so they match that way. X and 2 are part of the top of the triangle, so they match that way. Ladies and gentlemen, notice that the 4 is always at the diagonal. And notice the 4 is always at the diagonal. And so you can use that little bit of pictorial understanding as well, because it's coincidence, but it's going to be pretty consistent. And so we can actually solve this then. I'm going to solve the first one just because I wrote it first. And ladies and gentlemen, we're able to do that pretty easily. Multiply by 2 on both sides. The 2's cancel out on the side with the x. So our value of x is equal to 7 times 2 over 4, which is equal to 14 fourths. Now, ladies and gentlemen, you could also just reduce your fractions, and I guarantee you should reduce your fractions. 14 fourths is the same thing as 7 halves, and this is normally where I'd prefer you to leave your answers. But in this particular quiz this week, it's going to be asking you to type it in as decimals. So when you get to 7 halves, know that is a perfectly reasonable and excellent answer. But take the extra step and write the numerical value of 3.5 for this week's practice. It's always good to practice decimals, even if we, may not use them as often as improper fractions in mathematics. They are incredibly valuable and useful. So, ladies and gentlemen, let's look at another fraction. Not another fraction. I mean, that'll happen too, but another practice problem. All right, ladies and gentlemen, so in this next practice problem, I want to illustrate a non-example. So let me emphasize that here. This is going to be a non-example. Why? Because in this particular example, we will not have the side splitter theorem. Yes, we have parallel lines, and yes, these sides are being split by the side splitter theorem. But if I gave you a 5 and a 3 on this side, where it actually is being split, but instead of giving you the other split side, so you could actually match them up and solve, I'm going to instead give you the 4 and the x here on bottom with our parallel lines. Ladies and gentlemen, if you have an example like this, you are not using the side splitter theorem. And the reason is because this x is not split by your parallel line. This x is not in this spot. And so it does not follow the side splitter theorem rules. Instead, in order to solve this problem, you have to go back to what we know and love and used before, which is looking at the image and the pre-image and setting up your fractions. Because that way you can guarantee you're going to be solving for the full side of x, which requires you to use the full side of the triangle instead of just the 3. So you have to use the 8 instead of the 3 when you set up your fractions, and it's good to track the image over the pre-image so you can make sure your answer comes from the right steps. So here we have the 5 and the 4. 5 and the 4 is fantastic, and the 8 and the x. So 5 corresponds with 8. I'm going to go ahead and pick the 8 to be the image because x is part of the larger triangle as well as 8. So since those are the larger triangle, I'm going to pick those to be the image. So 8's going to go on top. Boom. The 5's going to go on bottom. And that's going to be equal to the x on top with the 4 on bottom. And this we can solve, but ladies and gentlemen, notice in order to get this fraction in our Seahawks colors, that was coincidence and not intentional. Although, sports, go sports, woo! So, in order to get to this point, we had to use the full side of the triangle. We had to use the full side of the triangle because we're not using our side splitter theorem. And so, just to walk through the steps, multiply by 4 on both sides. And ladies and gentlemen, when you multiply by 4, 4 times 8 is 32. So you have 32 fifths equal to x, which means you end up with your value of x written as a decimal, 6.4. All right, let's take a look at another example here. All right, ladies and gentlemen, so this example is an example of the side splitter theorem, and the way we know is because of the fact that we have a parallel line intersecting our two sides, breaking them up into proportional parts. And so we get to set this up any way we like. I'm going to choose, because I am a free agent in the world, to match up the x minus 7 and the 18 together, and to match up the 8 and the 12 together. And by doing that, I'm going to be able to make my fractions. I'm going to put the x minus 7 on top, and the reason why is because, it's the variable. It makes it easier to solve, which then puts that over the 18, and in my other fraction, the 8 is on the same side as the x minus 7, so the 8 goes on top with the 12 on bottom. Now, ladies and gentlemen, we can solve. Let's go ahead and take our first step and to multiply by 18 on both sides. Boom, boom. The 18s cancel out on the side with the x minus 7, which then gives us 8 times 18 divided by 12. Whew! Calculator geniuses, let's knock this one out. Eight times 18 is 144. And ladies and gentlemen, I know 144 is 12 squared. So 144 divided by 12 is 12. Well, that was convenient. I expected to have to multiply by 12 on both sides to get rid of my fraction here, but instead it canceled out. So I just need to worry about getting x by itself and adding by 7 on both sides. So add by 7, ladies and gentlemen, our value of x is equal to 19. Ladies and gentlemen, just as a clarifying point, 19 is not the length of this segment. The length of the segment is 19 minus 7, which was 12, admittedly. But, ladies and gentlemen, the length of this segment is not the value of x here. The length of the segment is the value of x minus 7. So, with that clarifying point made out, ladies and gentlemen, I hope that helps you out. If not, please email me. I'm more than glad to help. And I look forward to seeing you in the next video. Take care.